Thank you. I'll record now. So for those that are watching the recording, sorry, I forgot to hit record. Tangent 46. Let me see. Let me make sure I have the right thing. 13 divided by tangent 46. Oh, yeah. Why do I have 18.1? Oh, because I copied the wrong number. Yes. So, you guys are right. If you have 12 something, that is correct. 12.55. Yeah, I do have that correct on my paper. I just copied the wrong number. So the next problem we're going to do, the next part, to find C, we're going to get 18.1. Okay, so yeah, 12.55. If you punched it in your calculator, you got 13 divided by tangent 46 is 12.55. You are correct. Okay, so I found B. So now I know that B is 12.55. Now the thing is I rounded that, right? So if at all possible, I want to try to figure out what C is without using the 12.55. So I want to go back to my picture and look here. Here's C. I have this 13. Can I figure out a way to use the 13 and one of these angles to figure out what C is? Anybody have any ideas? I want to avoid using the 12.55. So sure, I could use the sine. So the sine of 46 degrees is going to be equal to the opposite, 13, divided by the hypotenuse, which is C. So again, if I multiply up, C sine 46 degrees is going to be equal to 13. Divide both sides by the sine of 46 degrees. And I'll move this up here in a second. So, C, this time, we should get roughly 18.1, right? Now I'm going to double check myself just to make sure. Yeah, so 18.1 if you round to the nearest tenth, right? And Alex tells you what you need to round to. In terms of the test, I'm pretty flexible. If you round to the nearest tenth or nearest hundredth, either one I'm okay with. Questions? No? Okay, should we try another one? All right. So sometimes the problems, they don't draw the triangle for you. They actually just give you what the things are. So we're going to say little a is equal to 8.6. Little b is equal to, oops, I wrote that wrong. This way, let's make sure things match up with my notes. Little a is equal to 2. Little b is equal to 8.6. And capital C, again, in this case, is 90 degrees. So again, if I draw my picture, let me say this is A, this is B, this is C. So the side across from A is little a, right? This is going to be little a, this is going to be little b. So A is a 2, B is 8.6. And so we're trying to find, we need to find side little c, and then we also need to find angle A and angle B. So, any ideas on what we could try here? So, I'm happy to entertain any ideas. How to find one of the angles, or how to find side C. Okay, so if we want to find side AB, then, so if we're going to find the side right off the bat, right, since I happen to know the other two sides, what could I use here? Yeah, I can use the Pythagorean Theorem. So the Pythagorean Theorem says a squared plus b squared equals c squared, right? So in our case, 2 squared plus b is 8.6 squared equals c squared. So 2 squared is going to be 4 plus 8.6 squared, which I didn't actually write down what that was. Oops. So 8.6 squared is 73.96 equals c squared. So c squared is going to be equal to 77.96. And then we're going to take the square root of it. Now, generally, when you take the square root, if you're solving like this, you do a plus or a minus. We just have some random triangle sitting in space, so we're going to be working with the positive part. So it's going to be the square root of 77.96. So RC is going to roughly be 8.8. So this is 8.8. And as I said, the important thing to remember is that that is a rounded value, right? So I want to try to, when I'm trying to find the angles, I want to try to avoid using that 8.8. So can we think of a way to find either angle A or B that doesn't use the 8.8, just uses the other two sides? What do we think? Can you think of a trig relationship? So you have these two sides, right? So they're the two legs. So which trig function only uses the two legs, doesn't use the hypotenuse in it at all? Yeah, the tangent. So we could say that the tangent of A would be equal to the opposite side, which is 2, over the adjacent side, which is 8.6. Okay, so I have a relationship. How am I going to get the A out of that? What do I need to do to untrap that A? Not multiply tangent on both sides. Not multiply by 8.6. So those are both good. They're both good ideas. The problem with those two ideas are the following, right? So if you multiply both sides by tangent, you're just going to end up with tangent of tangent. If you multiply by 8.6, we're going to isolate the 2. We're not going to isolate the A. Okay, dividing by tangent. So the thing you want to remember is that the tangent is with the, this is an angle and it's attached to the tangent. So this is all one piece. You can't just divide this by tangent. Dividing by tangent doesn't actually mean anything. You have to, when you divide, you have to have the tangent of some angle. So tangent all by itself you can't do that. Just kind of like I think when I taught about sines and cosines, right? I think I used the little jokey thing to remind you, like it's a sin to leave sine by itself, right? So you can't ever just have the trig function without an angle attached to it. But somebody said use inverse tangent. And so yes, so remember we've solved things like this before. This is the same as saying that A is equal to the tangent inverse of 2 divided by 8.6. And your calculator has an inverse tangent button on it. So if you punch this in, you get that this A turns out to be approximately 13.1 degrees. Questions? Okay, so you need to do inverse tangent because it's kind of like the same thing. Like if I had like, say like the square root of x equals 5. To get rid of the square root, I have to do the inverse. I have to do the inverse function, which is I would square both sides. That's what gets rid of the square root, and would leave us here with x equals 25. So kind of there's like a middle step in here that I didn't write that you could if you wanted to. So if you wanted to write tangent, so we have tangent of A equals 2 over 8.6. You could think about what I really did was I took the inverse tangent of all this stuff is equal to the inverse tangent of all this stuff. And then tangent inverse of tangent, when you're doing the composition of an inverse function with itself, they cancel each other out. So you're left on the left-hand side with A and on the right-hand side with tangent inverse of 2 divided by 8.6. Does that help? Okay, good. So now we know that angle A is 13.1 degrees. So in this case, right, we kind of don't have a choice. We need to have all the angles of our triangle add up to 180 degrees. So we need to use that 180 minus, so we need angle A plus angle B plus angle C to be 180 degrees. So angle A is 13.1. Angle B we don't know yet. And angle C is 8.6 degrees. We want that to be 180 degrees, which means that B is going to end up being 76.9 degrees. So in this case, like, we have to use that. You could, technically you could do the tangent of B is equal to 8.6 divided by 2, but you will also get 76.9. And you want to round so that your two numbers end up equaling 180 degrees. So sometimes you have to use that rounded answer. We just try, if at all possible, to not use it. Questions? No. Okay. So that's kind of as like difficult, complicated as the, sure, yeah. So I got 76.9 by doing basically, if you add 13.1 and 8.6 together, right, you get 21.7. So we have B plus 21.7 equals 180 degrees, right? And, oh, why did I put 8.6? That's not what I meant to put. C is not 8.6, right? That's not right. Okay, C is 90 degrees, right? 8.6 is side B. I just wrote the wrong thing down there. So if you add 90 and 13.1, you end up with B is B plus 103.1 is equal to 180. And then if you subtract 103 from both sides, you get 76.9. Thank you. Yeah, I messed that up. You're my first class back after break, so I should say my first class where I've had to teach. I have a morning class, but that's kind of, it's run a little differently, so I haven't had to teach, so we're a little rusty here this afternoon. See, I don't even know if it's morning or afternoon. Other questions? No. Okay. So now what we're going to do is we're actually going to look at using these for word problems. So I know word problems are everybody's favorite, but hopefully it's not too bad. So solve Okay. So, a ladder is leaning. Oh, I see. You guys are lagging behind me. Okay, so ladder is leaning against a house. The angle of elevation is 61 degrees. And the top of the ladder is 14 feet above the ground. How far is the ladder from the house? So I'll give you guys a minute to kind of copy it down because I know it's a lot of writing. My general rule of thumb on these problems is that the very first thing I do is I draw a picture. So no matter what the problem is, the very first thing I'm going to do with the problems is draw a picture so that I can get a better idea of what is going on. Now, sometimes Alex is pretty nice to you and it draws the picture for you so you don't have to draw it yourself. But basically, we have a ladder and it's leaning against a house. So I'm going to draw myself a house. And there's the ground. So here's my house. A couple windows, a door. Put some windows on the first floor. And there's a ladder that's leaning against the house. Okay, and so it says the angle of elevation is 61 degrees. So when we're talking about elevation, we're talking about the angle to look up to something. So if you're elevating something, you're raising it up. So the angle of elevation is the angle to look up. So it would be as if there was a person laying on the ground there and like you put a protractor up to their eye, you'd be able to measure like how they were gazing up. So they're talking about this angle here being 61 degrees. And then they say the top of the ladder is 14 feet above the ground. So they're talking about this pink distance here. So this pink distance here is 14. And then we want to know how far the ladder is from the house. So they're talking about this bottom distance here. So what variable do you want to call that bottom distance? You call it anything you want. Okay, x. And this problem's pretty nice. We're going to assume that the house and the ground make a perfect 90-degree angle, okay? Now, that may not be completely true in the real world, right? It might be off a little bit, but we're going to assume it's a 90-degree angle. So, can we think of something that relates that 61 degrees, the 14, and the x? Yeah, tangent. So, this is really saying that the tangent of 61 degrees is equal to the opposite 14 divided by the adjacent x. And so if I multiply the x up, I get x tangent 61 degrees equals 14. Divide both sides by the tangent of 61 degrees. And x should end up being approximately 7.8 feet. Questions? not too terrible, right? Once you got the picture, it kind of hopefully made sense. I have 2 more that we're going to do. So 2 more word problems. So let's try another one. Does anybody need me to wait before I go to the next page? No? Okay. All right. So B, find the angle of depression from the top of a lighthouse that is 172 feet above the water level to the water line of a ship 1,054 feet offshore. Right. So, angle of depression. So if you depress onto something, right, you're pushing it down. So you're talking about angle of depression is an angle that's looking down. So I'm going to have here a lighthouse. So maybe there's my lighthouse. And, you know, the lighthouse is in the water, right? And, or at the edge of the water. And here we have a boat. So, we're talking about, the angle of depression is coming from this top of this lighthouse down to the water line of the boat. So they're talking about coming down into here. And the angle of depression is actually usually measured from a horizontal. So we need a horizontal line. So if you think about, here's the horizontal that's even with the lighthouse. So the angle of depression is actually this angle in here. So that's the angle that we're looking for. So when you're talking about an angle of depression, you have to go from a horizontal and then go down. So I draw that horizontal line, and then we're talking about going down to the boat. And that's the angle we're looking for. So again, it needs a variable. What do you want to call that angle? Okay, X. So we'll call this angle in here X. They tell us that the height of the lighthouse is 172 feet. So this distance here is 172 feet. Now, I'm trying to deal with this angle here, X. So I probably actually want to deal with a triangle over here, right? So we're basically dealing with this blue triangle. So I've got X. This would be a right angle here. And if I know that this side here is 172 degrees, or 172 feet, that means this is 172 feet. It's tall. And then the horizontal distance from the middle here of the lighthouse, they're saying is 1,054 feet. So that's going to be the same up top here, 1,054 feet. So now I've got my picture all labeled. Anybody have any questions about how I labeled those things? No. Okay, so again, I need something that relates all this stuff together. So what's going to relate that angle? Yeah, so again, it's going to be the tangent. So the tangent of x, so we don't know the angle here, is going to be the opposite, 172, divided by the adjacent, 1054. And again, this is one where we're going to have to use the inverse tangent to figure out what x is. So x is going to be equal to the inverse tangent of 172 divided by 1054. And if you plug that in, you get approximately 9.3 degrees. Questions? No. If we put an equal sign, no, if you put an equal sign, that's fine. Yeah, I mean, these problems, they're going to make you round. Alex will tell you how many decimal places they want you to round to, but yeah, you're going to have to round on these problems. No problem. Other questions? No? Okay. So, a surveyor wants to know the length of a tunnel. Built through a mountain. According to her equipment, she is 243 meters from one entrance at an angle of 47 degrees. Oops. To the perpendicular. Also, according to her equipment, she is 186 meters from the other entrance at an angle of 27 degrees. Oops, to the perpendicular. How long is the tunnel? Ugh, it's a lot of writing, right? It's a problem with word problems. It's also the problem with us being virtual, right? Because generally when I teach these, I pre-type all the word problems and I just give a handout that has everything typed on it, the problems, so that then you don't have to spend time writing the problems, but it doesn't work as well in the virtual environment, so I figured I'd just give you time to write the problems. Okay, so a key to this problem is actually understanding the picture. And the picture is actually a little bit hard to get just from the problem. So the problems that are like this on Alex, they actually do draw the picture for you. But basically what's happening is there is basically like a mountain, And the mountain has a tunnel through the two ends. So here's like the entrance to the tunnel, and then here's the other side, right? And the technique here that I'm going to show you, so these are like the entrances to the tunnel. So the technique I'm going to show you here, you can use if you want to measure something that you know is straight. Okay, so we're going to assume that the tunnel in this mountain is exactly straight. Most tunnels through mountains are not exactly straight, but we're going to assume that our tunnel here is straight. And basically what happens is a surveyor stands in a certain spot. So maybe the surveyor is standing, say, like here. And what they do with their equipment is they measure the distance from where they're standing to the endpoints. So they're going to measure this distance and this distance. And then they also measure the angle that they're at. So here, so this is what they mean, the angle to the perpendicular, right? So there's the perpendicular. So it says the one entrance is an angle of 47 degrees. So they're saying that this part here is 47 degrees and she is 243 meters to the entrance. And then the other side, it's saying, oh, her angle is 27 degrees. Now, obviously, my picture is not drawn super well to scale, right? But 27 degrees. And then her distance on that side is 186. So basically, we have two triangles, right? So we have this pink triangle. And then we have this blue triangle here. So I have two triangles that I'm going to work with. And I can find the length, that top length, in each of those two triangles. So in the blue triangle, why don't we call this top length here X? And in the pink triangle, we'll call the top length here Y. So our final answer, we're going to have to find X, find Y, and add the two together. So with the information that we have right now, like the knowledge that we have right now in the course, we don't have enough information to be able to do it all in one step as one problem. After section 6.3, we actually would be able to do it all as one problem. We wouldn't have to do it here, splitting it up as two problems, but you can definitely split it into two problems like this. So if we go with the blue part first, can we think about some kind of relationship that relates the angle 47, the side 243, and the side X? Close, not cosine, but... So remember, yeah, so it's sine. Remember, cosine would be the adjacent, which would be this side here over the hypotenuse. We want this side here, which is the opposite of the 47. So it's across from the 47. So it's the opposite side over the hypotenuse. So that's going to be the sine. So for the blue one, we're saying the sine of 47 degrees is going to be the opposite X over the hypotenuse, 243. So if I multiply the 243 up, so we have 243 times the sine of 47 degrees. And if you work, so you can work that out to get what the decimal approximation is. I'm not going to do that yet because in the end, we want the two added together. So I'm going to wait until we actually get both pieces and add them together, and then we'll just round at the very end. So we're only rounding one time, right? Remember, we're trying to limit the amount of times we round, because every time you round, you're making a little bit of an error. And if you keep making a little bit of an error and then using that number and making a little bit more of an error, it makes your error a lot bigger. So we're going to do the same thing for the pink side. So again, for the pink triangle, it's also going to be the sine. So the sine of 27 degrees is going to be equal to the opposite y over the hypotenuse, 186. So y is going to be equal to 186 times the sine of 27 degrees. And then I need to add those two together. So x plus y is going to be 243 times the sine of 47 degrees plus 186 times the sine of 27 degrees. And if you do that, you should get approximately 262.2 meters. Questions? No? Okay. Then, that is section 6.1. It's actually all of section 6.1. So, it's kind of a nice ease back into class this week, right? Yeah, it's not too bad. Section 6, I actually don't think chapter 6 is that bad. It's just that stuff, takes a little bit more time because you're working with some uglier numbers, I should say. But otherwise, I actually don't think it's too bad. Does anybody have any questions before we go? Yeah, so a lot of the problems, they actually do pre-draw for you. So, and it's not, your triangle, like this problem, so on the exam, I give you a take-home exam, and, I do draw some of them, yeah. And the ones where you have to draw the triangle yourself, it's pretty, it's easier for you, I shouldn't say, they're ones where it doesn't matter how you draw the triangle, as long as you have little a across from capital A and little b across from capital B. So other questions? There might be one problem on the test that you have to, so the take-home test will actually be, we're going to do, so it's not after we do everything that's left. So basically the take-home test covers chapter 6. So we're going to do sections 6.1, 6.2, 6.3. And then once we have finished 6.3, I will put the take-home test up and then let you guys know. And you'll have a week to do it. So it's basically just kind of like you could think of it almost like another assignment you have to do that week. And then the only other thing we have after that, besides homework, is the final exam. Does that make sense? No problem. Yeah, there's really not too much left in our course. We've actually done the hardest stuff, I believe, in our course. At least that's my opinion, right? We did all the really meaty, important stuff before spring break. All right, sounds good. See you guys all on Wednesday.
Miss Gorman?
Mm-hmm.